Hello, this is Timothy from Vayo Technology. In this video, I will demonstrate our 3D DFM solution, the Vayo Pro DFM Expert. Vayo Pro DFM Expert can virtualize the 3D PCBA and demonstrate high capability DFM rule checks automatically to optimize your DFM cycle and generate a unique 3D report. Intuitively and ingeniously, it can present the real issues and your DFM capability as well. Based on continuous innovation, Vayo Pro DFM Expert received the IPC Innovation Award in California, United States, and more awards in China and Southeast Asia. We shall presenting more solutions in the future. And back to the software. As we all know, involving the DFM process can effectively predict the manufacturing defects, increasing the product quality and reliability, also to reduce the costs, MPI cycle, and time to market. With the Vayo Pro DFM Expert, we can use the real component modules, virtualizing a 3D PCBA, and running the flexible rule checks to unveil the hidden risks of design, prototyping, mass production, and etc. Also, these rules, you can feel free to form up your own rule sets for different customers, different production lines, different project families, and etc. And eventually, a unique 3D report you can share with the customers, showing to them of the issues in a very intuitive way. Before we go to demonstrate the software, I will tell you the mechanism of our tools. First, we're going to introduce the PCB data and merge with assembly BOM. Then, under the help of component library, the 3D module library, we will virtually assemble the entire PCBA. And afterwards, we will go to the core of DFM inspection, the automatic rule check. And eventually, we will form and get the 3D DFM report as a final result. Now, let's follow my lead to the software. The first thing you will mention in the DFM software is the flowchart. Follow it one by one, and eventually you will get the DFM result. You never forget where you are, and also making the software very simple to learn. Now, let's introduce the PCB CAD file. In this demonstration, we will show you which CAD interface we can support. You can find the famous Cadence system, Mentor, and Altium designers. Also, you can find some famous third parties as ODB++ and IPC 2581. Other formats are also listed. Do not worry if you cannot distinguish them. Simply load in the CAD file, and our software can tell it for you. In a Vayo Pro solution, we will introduce layer by layer, net by net, and component by component to recreate the PCB and show it to you on a 2D level. After introduce the CAD file, you can check each layers from the layer window. You can check the component package or uncheck it. Nevertheless, we're going to introduce the assembly BOM to merge with current CAD file. Vayo solution can adapt to various kinds of BOM formats. Simply make a BOM parser and check those BOM by some of the conditions, and you will get a BOM verifying result. For example, here we find 3 references from the BOM, but the quantity equals 2. There is something wrong. Don't worry, this one will go to the final DFM report. And secondly, you will also get a BOM and CAD merge report. This validation shows which parts in BOM, not in CAD. Be aware, this one you can't find a reference to assembly. The other conditions also can show. Now, we're officially into the second stage. We're going to virtualize the assembly using the component library and auto placement to make sure the assembly in the correct location. In Get Component step, we will visit the virtual component library, which has also been saved in our 3D modules with different parameters. As you can see in these pictures, different component and their body, pin, or even polarity marks are shown with you. But more parameters are saved right here. That's what we're going to do. We're going to match the manufacturers to narrow down the searching area, and then I will going to search and assign the component from the library. Now, after the matching is finished, you can check some of the component modules, and hey, you can find some alternative materials on here as well. That explains the third step, an AVL check. Software can use the 3D component modules to compare between the main material and alternative material and expose the difference in between. For example, here, the red outline is the alternative part. As you can see, it is not good enough for this pad design. We're going to save this into a report. If you like this intuitive way of checking your alternative component, please let us know if you have other suggestions. Now we have finished the step. Automatically set the assembly process for different components for the future rule checks. You can set another component assembly process by yourself. And here we're at the first very important way of verifying the component DFM assembly issues. In here, we're going to automatically verify the assembly issues, correct the rotation, and expose the most severe assembly issues. For example, this component is a bad selection for this pad. We're going to save a report. Then, for some of our projects, you also want to unveil the mass production and hidden issues. If you cannot see it or cannot verify it by placement, you're going to run some automatic rule checks. Confirm the PCB reflow side and wave side. Then we're going to run the DFM rule checks. Here, as we talked about, you can set different rule groups for different purposes, different projects, different customers. Today, we're going to show you with our standard rule sets. A lot of the rules here, you can pick it up and put into your new rule sets. Allow me to jump to a few minutes later to show you the results. Okay, now the automatic analysis is finished. Let's sort some of the results into the reports. In this interface, you can click upon the buttons to show each of the rule items and click on this result interface and jump between different violation locations. And of course, let us not forget this is a 3D DFM analysis tool. The 3D board window will give you a best intuitive viewing of the issues with the 3D virtualized PCBA. Feel free to zoom in, zoom out, and rotate. Very easy to find a grid angle, and most important of all, take a good 3D pictures so that this result will be added automatically into the final DFM reports. Now, due to the time reasons, I have already sorted some into defects. Let's check for some of the typical issues that I have done before. For example, the component and component distancing may be the most easiest violation we can find the 3D functions. As you can see here, some of the fragile capacitors has been too close to a high and tall connector TH. You can see the recommended value. It is a part of our rule structures. If you're interested in the rules, feel free to contact us. We have many interesting stuff to share. Besides the component and component distancing matrix checks, there are also other tools that you can see of. On the 2D, this rule pictures, if you take it here, may not give you an intuitive seeing what this is. But if you check on 3D and change the blinds, and you will see it is a fiducial covered by the components. Also, you can see other reports like this one. On the 2D, it is very hard to identify what is this kind of issues with one eye. So on 3D, we make a picture instead, showing you this is the violation that a component is activating on the keep out area of the DIP on the opposite side. Also, the software can show you the fine pitch component on each of a location so that engineers can take a closer and better look, see if there are other things we're forgetting of. Now, it's time to see the final DFM reports. Select the template of your DFM report. If you want your own unique template, let's talk about that customization service. In the report template, you can see many different contents. Like you can see, a summary of a final DFM report, the risk categories, the passery of the checks, and let's not forget an overview and 3D virtualized PCB pictures for everybody's understanding. As we have checked the failed alternative parts and most of the severe assembly difficulties that we have found before the total DFM analysis. And here are some of the violations or the hidden risks that we have found according to the massive DFM rule checks. You can see the real component modules, the example pictures, precautions, recommendations, giving you a very good understanding and transform the knowledge between engineers and another engineers. For example, the fiducial mark covered by components, now shown very intuitively. You can find the location, and you can find the standard value, which is the value you can accept. Of course, this one you can edit your rule manager interface. So in rest of this demonstration, I will show you some of the typical results. If you're interested, please proceed. Fiducial to expose the pad. It could be causing some mislead and reduction the recognition accuracy of your visual or optical equipment. A fiducial too close to the coverage edge, that might the fixture would cover it. The DIP other side keep out area violations. The fine pitch SMDs. Component to a tooling hole See the side, the component reference, and the coordinates. Expose the via under the components. SMD component too close to a pin through hole. And of course, run reference descriptions. And also some IPC standard rules. And here you can see the gap of a certain package. Another one for 0805. Also for the pad length, pad width, and others rules from IPC, the heel, the toe, and on the sides. Also, annular ring can be found very easy. Check with the fabricators to see if this annular ring is possible. And with our 3D component library, you can find the component pin are also created. Hence, you can check the pin and hole matching. If there is not a suitable size between the pin and hole, you might find some different issues with soldering or assembly. Distancing rules, you can manage them to different rule sets. For example, this component too close to a PCB edge problem, we can also sort them into a reflow rule class, showing that this violation can cause different kind of difficulty for different kind of process. You decide. Solder paste missing, thermal issues with inner layer designs and other tools. The wave soldering, solder mask distance, that you can find different stuff. With drills, you can define the hole on SMD pad problems and via hole offsets. So as you can see, even so, some of the issues with fabrication or bare board, you can also find the 3D pretty good to show on these problems. The odd angle, and of course, the circuit shortage. These two are linked together, but they're from different nets. Other kind of different situations, like lying to a via too close. The line is pulled from the wrong direction from the pad. And of course, the missing of teardrops. And with silk screens, you can find silk screen covering with the drills. With solder mask, you can check all missing solder mask pad and other violations with mask annular rings, of course, which I didn't show in these pictures. With the test point, you can see a test point being too close to a tall component. You can set different height levels according to the rule structures. And here is the second level or third level of the height difference between component and a test point. And also, you can check if there's no test point to some of the nets, like a very roughly testability report. Also, you can count the test point quantity on the ground nets and other nets. And at the end of this report, you will see the BOM verification and BOM CAD verification. Last but not least, you can export this report into different formats and share with different engineers. Okay, thank you for watching. If you have any other questions, please contact your value personnel or your sales representative for further assistance. This is Timothy. Thank you for watching. Timothy's out.